Hello friends, let us start solving the problems based on KVL and KCL. In this video, we will see the remaining problems of the same topic. Problem 16 as appeared on the screen. So they are asking us the circuit shown in the figure represents what? Whether it is voltage controlled voltage source, voltage controlled current source, current controlled current source and current controlled voltage source. To understand this, we will try to understand dependent sources first. So what is meant by dependent sources? For example, we can have four types of dependent sources. Dependent sources are always indicated by using a diamond shape. Now, dependent sources can be voltage source or current source. Whether they are voltage source or current source, that is indicated by either polarity or direction. If there is a polarity inside a diamond, it is voltage source. If there is an arrow, it is a dependent current source. So, in first I have written plus minus, or it can be minus plus, it can be, let's say, some upward arrow, or it can have downward arrow. So, the first two sources that I have drawn are dependent voltage sources, and the remaining two are called as dependent current sources. So these two are dependent voltage sources. So I will say this is dependent voltage source, DVS. Second is also dependent voltage source, DVS. The third is dependent current source, so I will indicate it as DCS. And the last one is DCS, stands for dependent current source. Now we have to also see a magnitude of it. For example, the magnitude given for the first source is, let's say, 2Vx. What does that mean? The magnitude of this is not fixed, rather it depends on Vx, where Vx will be some voltage in the same circuit. If that Vx changes, this magnitude will change. For example, if Vx equal to 0 volt, what will be the magnitude of this? It will be 0 volt. If Vx equal to 1 volt, what will be the magnitude of this? It will be 2 volt. So it depends upon the value of Vx. And what is Vx? Vx is another voltage, and that is the reason why it is called as voltage dependent. So on what factor the magnitude depends? The magnitude depends on voltage. Therefore I'll write VDVS. Now what VDVS stands for? Voltage dependent voltage source. So the factor on which it depends on should be the first character. Let us see the second source. In the second source, assume the magnitude as, let's say, 5 times IY. It means the magnitude of this voltage source is also not fixed. It depends upon the value of IY, where IY will be the current within the same circuit. If this IY changes, this magnitude will also change. Let's say if this IY is 5 ampere, then the magnitude of this voltage source will be 25 volt, and so on. So the magnitude, since it depends upon some current, I should write the first character or the first alphabet as C. In effect, it becomes CDVS, stands for current dependent voltage source. Understand, it is voltage source which is dependent type and it depends upon some other current, so it is called as current dependent voltage source. Let us see the third type. In this, it is a dependent current source, dependent because it is a diamond, current source because it is having an arrow. So, looking at the magnitude, we will understand on what factor it depends on. Suppose the magnitude is 3 times Vz. It means the magnitude of this current source depend upon the value of Vz, where Vz is some other voltage, so the first alphabet becomes V. So in effect it becomes VDCS, stands for voltage dependent current source. Whereas in the fourth type, if I assume the magnitude of this as 5 times, let's say, IZ, It means the value of this current source depends upon the value of some other current, and therefore the first alphabet becomes CD, CS. The first alphabet becomes a C, so in effect it becomes CDCS, stands for current dependent current source. So understand, voltage dependent voltage source, which is the first type, is also called as voltage controlled voltage source, whereas the second type is current dependent voltage source, is also called as current controlled current source or current controlled voltage source. So in this type, as you can see, the dependent source which is given is a current type. So I would say it is a dependent current source. On what factor it depends upon? It depends upon II, where II is the another current which is shown over here within the same circuit. Therefore I would say it is current dependent current source. But the other analogy says it can be current controlled current source also. So current controlled current source, as you can see, it is option number C. So option number C is the correct option. Let us go to the next problem. Let us start with problem number 17. In the given circuit, find the values of V1 and V2, and options are given. So let us solve this problem. So as you can see, in this circuit we have to find the value of V1 and V2. V1 is the voltage across the current source, which is 2I, and V2 is the voltage across the another current source, which is 5 ampere. So as you can see, there are two resistances which are connected in parallel, which is 4 ohms and 4 ohms. Through 4 ohms, the current which is given as I, then I can also assume the current through this 4 ohms also I. So if this is I, then if I consider this node, this is incoming current I, this is outgoing current, which is, let's say, 5 ampere. One more current coming over here is I. There is another current which comes in the last branch, which is 2I. So after applying KCL at this point, I can say that I is incoming, another I is incoming, the other incoming current is 2I. Summation of incoming should match with summation of outgoing. So by applying KCL at this node, I can say I plus 2I should be equal to 5, which is 4I equal to 5, or I can say that I is equal to 5 by 4 ampere. So what we have got finally is the current I. The reason why I could assume the similar current through 4 ampere, because both the resistors are connected in parallel having the same value. So once we have the value of I, let us see what we can do to get the value of V1 and V2. As you can see, the V1 is the voltage across the dependent source 2I, to which there is another parallel resistance connected 4 ohms. We know the fact that voltage across parallel circuit is same. According to that theory, I can say that voltage V1 will be voltage across this 4 ohms also. So by applying now Ohm's law, V is equal to I into R. So I can claim that V1 will be equal to current through 4 is, let's say, I times 4. So V1 will be equal to 5 by 4 into 4. So 4 cancels out. V1 becomes 5 volt. So the value of V1 which they were asking us, we will record this value. So now we have to find the value of V2. The value of V2 can be found out very easily by applying KVL to this loop. So if I apply KVL to this loop, what equation do I get? When you are going clockwise, you start with this negative terminal of V2, you get positive V2, that is negative to positive, positive V2. Then voltage across this having polarity like this, which is minus 4 times 5 ampere, because 5 ampere is the current source which is given with the direction like this. Then positive to negative will be negative times 4 times I, where I is 5 by 4, and this whole will be equal to 0. So here 4 and 4 cancels out. So now value of V2 is equal to 4 5s are 20 becomes positive 20, and this negative 5 becomes positive 5. In effect, I'll get V2 value as 25 volt. So the value of V1 that they were asking us is 4 volt, and the value of V2 that we have got right now is 25 volt. So now we will go back to the previous slide and we will see for the correct option. So we had 4 options, out of which 5 volt and 25 volt is a correct option, which is option number A. I'm sure you have understood this problem very well. With this, now we can start with the next problem. Let us start with problem number 18. Of the networks which are shown, N1, N2, N3 and N4, which are listed here, this is N1, this is N3, N2 and N4, which are given. The networks having identical driving point functions are N1, N2, N2, N4, N1, N3 or N1, N4. Now, identical driving point function means either having identical Z of S or identical Y of S. Z of S stands for impedance function and Y of S stands for admittance function. We know the fact that it is easy to calculate impedances when elements are connected in series, whereas admittances are advisable when the parallel circuit is given. In this case, as you can see, the parallel circuit is given, so we will try to go for admittance calculations rather than impedance calculation, and accordingly we will verify which networks are identical to each other. Let us start with the solution now. Please understand, whenever you have R, you can keep R as its Laplace transform R only, having unit as ohms. When you have inductor L in Henry, after Laplace transformation it becomes Ls times ohms. Whereas if you have got capacitor in farads, you can replace capacitor as 1 upon Cs ohms. So by taking Laplace transformation of every network, what we get? I can represent 2 as 2s. I can represent this 2 as 2 ohms only. This one should be replaced as 1 by s. Whereas this has to be also replaced as 1 by s. So now what do I get is, I can have Y equivalent for network 1 as Y1 plus Y2 plus Y3, where Y is nothing but admittance of this. If you see, this is a series connection, the equivalent impedance of this can be taken as 2s plus 1, or I can say admittance of this will be inverse of the impedance, which is 1 upon 2s plus 1, plus Y2 will be, the impedance of this is 2 plus 1 by s. So admittance will be exactly reverse of it, which is 2 plus 1 by s, plus Y3 can be taken as 1 upon 1 by s. So after solving, what do I get is 1 upon 2s plus 1 plus s upon 2s plus 1 plus s. So after solving this, you can see the first two terms are having equal denominators. I can combine this s plus 1 upon 2s plus 1. After cross multiplication with 2s plus 1, this third term becomes 2s square plus s. Resultant, what we have is 2s square plus 2s plus 1 upon 2s plus 1. So this becomes Y equivalent for network number 1. So we shall record this, the value of Y1 as 2s square plus 2s plus 1 upon 2s plus 1. Likewise, we will now try to solve network 2 also. So solving for network 2, as you can see, there are two impedances which are connected in parallel. I can represent this as 2s plus 1, and this impedance can be taken as 2 plus 1 by s. So 2s plus 1 in parallel with 2 plus 1 by s. Rather, I can calculate Y equivalent for this as Y1 plus Y2. So Y1 will be inverse of this, which is 1 upon 2s plus 1, plus inverse of this will be 1 upon 2s plus 1 whole divided by s, which comes up here. So looking at the denominators, I can club them together having equal admittance as s plus 1 upon 2s plus 1. So this is y equivalent for network 2, which is s plus 1 upon 2s plus 1. So accordingly, let us solve last two networks also. So let us start with network number 3. So network number 3 is having this element as 1 parallel with 1. So 1 should be replaced for inductor as 1s. So it will be 1 into s upon 1 plus s, which is s upon s plus 1. So what we can see is value of first impedance Z1 can be taken as 1 plus s upon s plus 1. After solving this, what do I get is s plus 1 plus s upon s plus 1. In effect, it becomes 2s plus 1 upon s plus 1. And for the second branch, as we can see, there is a capacitor. So C is replaced as 1 upon Cs. So this becomes 1 upon S. So Z2 is 1 by S. But what we calculate is Y. So Y will be equal to 1 upon Z1 plus 1 upon Z2, which will be equal to the value of Z1 was 2S plus 1 upon S plus 1. So 1 upon Z1 will become S plus 1 upon 2S plus 1 plus the value of Z2 inverse as S, which can be equated as S plus 1 plus 2S square plus S whole divided by 2S plus 1, which will in effect becomes 2S square plus 2S plus 1 whole divided by 2S plus 1. So the value of N3 can be recorded as Y equivalent as 2S square plus 2S plus 1 whole divided by 2S plus 1. So let us go to the previous slide and record the value of N3. So the value of N3 that we have got is Y equivalent as 2S square plus 2S plus 1 whole divided by 2S plus 1. So the only effect, so the way we have solved for N1, N2 and N3, we will try to solve for N4 also. So solving for N4 now, as you can see, this 2 Henry should be replaced as 2S. So the impedance for first branch becomes 2S plus 1 and impedance for the second branch becomes simply 1 by S. We are calculating Y, so it will be 1 upon 2S plus 1 plus S. So now Y becomes 1 plus 2S square plus S whole divided by 2S plus 1. Finally, I can write Y as 2S square plus S plus 1 whole divided by 2S plus 1. So we shall now record this Y equivalent value for N4, which is 2S square plus S plus 1 divided by 2S plus 1. So now if you compare the value of N1, N2, N3 and N4, you will come to know that N1 and N3 are identical one because their Y equivalent are same. So what is the correct option? It is option number C. I'm sure you have understood all the problems in this video. Thank you so much for watching the video. Stay tuned to Ekeeda. Subscribe to Ekeeda.